Hello, I am Neeraj. Today I will explain how we can use LLM as judge. These days, people are using LLM as a judge in a lot of open-ended text areas. For example, question answering, guided summarizations or normal summarizations, code reviews or code-based reviews. A lot of different areas are there. So here, the major goal is to use LLM as a judge and evaluate the text based on or against some predefined rubrics. Also, we try to utilize some mathematical models to get more in-depth information about the judgment. And the goal of such kind of evaluation is to get a very much similar kind of evaluation score that we used to get through human evaluation. So this is the main goal. Now, to evaluate open text by using LLM as a judge, the major role of such strategies, how we utilize LLM for different types of judging modes. This is very important. So first part is absolute scoring, that is rubric based. Rubric means set of criteria that we utilize in evaluating our targeted text. It may be like correctness, faithfulness, safety, etc. For example, suppose you are a reviewer of a research paper. Your rubric will be like how much novelty is there in the paper? What is the depth of concept covered in the paper? What are the writing quality of this paper? Grammatical correctness in the paper, flow of the paper, readability of the paper. So these many rubrics, not just limited to these many, but this may be some minimum set of rubrics that you will fix to evaluate the actual quality of the research paper. So similarly, you can decide your own rubrics to achieve your own evaluation goals with full fairness. And here you can convert those scoring into absolute scoring, means it will be like a 0 to 5 scale, 0 to 10, 0 to 100 scale, like that. Second is pairwise comparison. Several times we try to compare two outputs A and B. So in that case, again we have to decide some rubrics and then we can take the decision that okay, A is better, B is better, there is a tie between them, like that. Third is explain and then score. So several times our text may be highly complex. So in that case, we try to decide a set of rules or some evidences or some policies so that evaluations go into that directions only and we evaluate the quality of the text based on each of those directions. Third and fourth is the committee of judges. This means the easiest and most basic way is to take the multiple LLM as multiple judge and then use the above techniques and then just calculate the majority voting. But another better way may be like use some mathematical models to know more better insight about the text. So we will go with this model. These are not just a final way to say that we have done with the evaluation. There are a lot of new techniques are there that you can utilize. So in this evaluation, suppose we are taking two systems, system A and system B, and both systems are generating some guided summary for a given text. Means summary in the context of some information or in some context. And now we are designing a system which can generate the evaluation. So this is a very basic system. You can develop a very advanced system on the top of this. and I had supplied the complete working code and demo for this system. So the first part is define your task and context, define the rubric. This is most important thing. So here our rubric is correctness, faithfulness, completeness, clarity, and safety. So these are our rubrics. And based on that, we collect the candidate outputs, output A and output B. And after that, we set our LLM. Now we will check that if the trials are remaining or not. If no trials are remaining, means we have to go for evaluation, directly evaluation. Here we are using the committee of judges with mathematical models. So we are using 3 different kind of mathematical models. So this is our first type of mathematical models. This is second type, and this is third type of mathematical models. First one is computing the Wilson confidence interval for winning rate. So here it computes that what is the range score for winning of a particular team. So in this case, the major issues bias kind of things, because several times what happens, this score works like that. In a several game you have seen that okay, player A has a 70% winning rate, player B has a 60% winning rate. Suppose player A and B will play, then who will win? So what is the confidence interval? So such kind of computations generally creates a huge bias. So that's why we added a model of bias diagnostics. And after that, there is another thing like a position bias gap value. So we will discuss about bias in the later section, that how it plays important role. And next strategy is Elo aggregation with K factor. So Elo aggregation uses the rating difference to predict the winning probability of a particular team. So Elo aggregations with K factors generally used in the chess game, where they use the ratings of rating difference between two players as a winning probability. For example, here two teams are there, RA and RB. Sorry, output A and output B. So if we say that RA minus RB, then that difference will indicate the expected score of winning of A. So here we will calculate the final Elo for A and B both, because we have to select from both, and then we provide the data here. Last is BTL aggregation. So this is a final aggregations. So BTL aggregation is a statistical aggregation mechanism that turns the pairwise comparison of results into global ranking, and then those global rankings are utilized for final to predict the final winning of A and B. So here we collect the BTL scores of A and B, and then we provide all the outputs here. Here it summarizes the results score, and based on that it takes the decisions. If trials are remaining, so in that case we are doing multiple operations. For example, we are trying to reduce the bias, chances of bias. We are also trying to complete the LLM related operations. For example, here the randomized orders are applied to reduce the bias, and then we build the message with rubrics and candidates. We call LLM, and if LLM is working fine, then parse the JSON output, and then schema is valid. Then we calculate the scores in between like 0 to 5 for under each rubrics, and then we provide all the details, and those details are coming here for final evaluation. So this is the process. Now the next important part is building good rubric. It is very important for any evaluations. So we will pick the dimensions: correctness, faithfulness, completeness, clarity, and safety. So that things we decided here, and we took the weight like 0 to 5, or we can take 0 to 10 also. And after that once you define all the rubrics, you have to calculate the final weight. Means you can give more weightage to like correctness, less weightage to faithfulness. Like for example, here correctness got 0.4, faithfulness 0.3, completeness 0.2, clarity 0. Then we can get the final score. So this is a very important part. The next part is pairwise judges. How you can write the prompt order. So this is designed here, like how you can design your prompt order. So this is very basic prompt order designed here, like design the system, like how to reward, what the policy that we can follow, what is the task, what is the rubric, what is the number scale for the rubric, candidate A, candidate B. So take those text, then apply some instructions, then calculate the scores. So these are very important prompt part, how we can actually manage. Now come to the mathematical part. So global ranking, so BTL. So BTL we had already discussed. We take the pairwise scores. For example, here BI is the quality of system I and the probability that I beats J. Then it is calculated by using sigmoid of BI minus BJ. So Wij is the how many times I beats J, and Nij is the total I versus J matches. Then maximum log likelihood is calculated. So this score is actually used here in computing the BTL score. And based on the BTL score, we can normalize the BTL score also. And based on the normalized score, we can decide that who will win. Now the next part is online leaderboards. So we already explained online leaderboards means after every match, the scores will change. We already discussed about K. So here K is like a sensitivity of the score update. And all those ratings are actually based on that different tournaments. So for each tournaments or each time, the ratings are updated like that, and it depends upon SA minus. So SA is actually the actual score of A, and EA is the expected score or rating scores that is given. K is the sensitivity factor, which controls the sensitivity. If higher K value is higher, then it will be highly sensitive, but results may be noisy. But if K is less, then it will react slowly, but results will be stable. So based on that, here you can see that value of SA can be like 1, 0.5 or 0. So this indicates win, tie or loss. So Elo is a simple. So based on that, we will get the final output for team A and B both. So here it is discussed, and another final is like confidence and reliability. So this is another type of score. So win rate, here for probability of win rate is, this is winning and this is total number of match they played, total number of times they compared. So based on this formula we actually calculate. Now the very important thing is like biases, because it totally destroys our system if we fails to handle the bias. In designing the LLM-as-a-Judge practice, then it is very tough to get the fair evaluation. For example, position bias. Several times you can say that answer A is at position A and answer B as position B, and several times answer A is winner. Same thing is like order. Then verbosity or length. Several times LLMs confuses with larger length prompts. Self-enhancements. For example, if you try to judge the answers written by one kind of LLM like GPT, and at the same time if you try to judge the answers written by another LLM, then generally LLM prefers their own answers or in styles. This is very important. So we have to mitigate it. So what are the different process like blind randomization sorting? You can change the order. After also in the judges case, we can use some try break judge, length related normalizations rubric we can apply. We can say that do not reward verbosity, penalize the fillers if they unnecessarily use some fillers to increase the length. Some judicial rationale like before verdict, explain and then choose, like why you took these decisions. We also tried similar kind of practice in this example. Multiple judges plus aggregations. For examples, we already utilized these things. Consensus, BTL and Elo, then anchors and calibrations. Now the next is the adversarial checks. Here we include the trap items like equally, good, bad, pair, and then try to quantify the bias and after that we can remove it. Now we will explain this in our code. So we have written the entire system in Python 3.10. So here you can see the code. So I have used the Groq library, Groq API keys and our Llama 3 version 7.10. You can see here. And after that, here you can see that we have taken the seed. These are the simple things. We have implemented the Wilson CI confidence interval, like how to decide in our case, and then judge system prompt we have written, like you are a strict fair evaluation judge, follow the rubric exactly. So you have to add those kinds. You can add more sophisticated things also. So after that, we build the pairwise user prompt. So already discussed in the PPT. So correctness, here I already say that all the rubric is actually implemented through prompt. So LLM is responsible to use all the rubrics. So here for correctness, I have just written that factually correct and logically sound. But I have selected a very small sentence, a small prompt. You can make it more meaningful according to your context. So if you are trying to use it for your case in a different scenario, please try to change all those things. For safety, suppose here I have just used the no policy violations or harmful content. Clarity, clear, concise, well-structured writing. Completeness, cover all request aspects and edge cases. And after that, we have mock LLM functions. Here we just identified that we have two candidates, candidate A and B. Then we decided that win, tie, related things. Then we decided scores for each of those candidates. And after that, we just apply the parse the judges scores. So these are some basic functions. Now the judge pair related things for candidate A and B. So we are changing the order also to remove the bias that we already discussed in the PPT earlier. So some simple bias removal strategies we applied. Then we run some pairwise trials, like by changing order, swapping. So such kind of things we have applied. And after that, we calculated all the Elo update score, aggregate Elo functions we have written based on the formula that is used here. And then we just calculated all the scores, BTL scores from pairwise. So we calculated. I think these are very simple things. So that's why I'm not explaining. So pairwise report. So in the case of wins A, case of wins B, ties. So similarly, all the reports we calculated, and then we applied the confidence interval of B, confidence interval of A, Elo of B, BTL of A, BTL of B. So all results we are generated, and then we generated all the results, and then we use all those results pairwise report in finalizing all those things, and with the finalizations it will generate scores with some LLM explanation so that you can understand that why this is the result. So example, here we have taken example task. Summarize the paragraph in 1-2 sentences focusing on the causes. So this is our guidance. So example paragraph is like, yesterday heavy rain flooded several city streets. Drainage systems were clogged due to poor maintenance. As a result, traffic delays lasted for hours. So this is the example paragraph. So candidate A, they say that several city streets flooded yesterday, causing long traffic delays. Candidate B say that streets flooded yesterday because drainage systems were poorly managed and clogged, causing long delays. So it looks like candidate B is little better. So let us see, if we run this, then what will happen. So yeah, so when we run, so based on the scores, the explanation is like, candidate B provides a clear, complete summary of the cause of the flooding, whereas candidate A only mentions the effect. From the scores, it is clear that candidate B is the actually winners. Win A 0, win B 6, win ties 0. So total trial 6. In all trials, candidate B is the winner. And this is the win rate, this is the Elo rating, this is the BTL latent scores.